Hey everyone, welcome back to Cloud Concentrator YouTube channel. Today I'm going to talk about AWS Network Architect, how to create the architectures when we plan to build any pillar for a foundation. So network architecture is a foundation of your cloud networking. So anything comes in the cloud, first the pillar is the to have the networking setup done properly. So I'm going to tell you about the best practices that should be adopted when we plan to prepare any network architecture in the cloud. So I will take an example, set of example where I prepared the diagram based on two region. So I'm taking example of Singapore and Hong Kong as a region where AWS where we are going to maintain the workload, right? So before we start any sort of provision the workload, right, we make sure that no workloads are getting deployed in a default VPC. Every AWS account comes with its own default VPC. So make sure that default VPC doesn't have any workload and get so as well the best practice, I would recommend to delete the default VPC from each and every region so that your attack surface get reduced. Um, so yeah, so the having the network architectures, maintaining the proper CIDR ranges, right? VPC CIDR ranges, make sure that you know your scaling your infrastructure will be quite reliable. So think of this way, like you start your journey of cloud now today, but in future there would be a scaling of multiple different applications coming in the environment. So how you're if you have done the networking planning properly from starting itself, you will not end up with a problem where overlapping IPs happening. There is some disadvantage of monitoring and the network is not getting properly traced out for any kind of troubleshooting. So I take an example like I try to use a well architect best practice when I prepare the diagram for any sort of our customers. Um, so generally, take an example of I have just taken an example of the AWS organization, right? So where we mainly host a multi-account structure. So in my previous video, I have also mentioned like what is the benefit of having a multi-account structure instead of hosting the single account, right? Multi-accounts gives you the isolations controls and it makes your data and application running an individual account without any uh, uh, um, if any kind of attack or if any kind of data breach happened in one single account, it won't get scared, it won't get spread across to your multiple account if you have a proper isolation done at the network level. So yes, networking is very important. So coming back to the architecture diagram. So suppose you have already designed uh, mm, the AWS infrastructure, like you have the organization setup done, and under that I managed to create three accounts. So three account where I'm going to host the use the Singapore region and host the application on that, right? So I have the environment called production where I'll be deploying my first setting up the VPCs, right? And the second would be like the staging environment where all your non-prod asset will be getting deployed. I'm also going to host one more in our production. This is for the separate applications. So we have a two prod, one stage, right? Um, so when we provision a new account, practice is to delete the default VPC, and then next thing like plan your VPC CIDR range, right? So suppose your organization is already using in on-prem as a 172 or 192 private IP ranges. Make sure that you don't use the same IP ranges, right? Try to use separate IP ranges in the cloud. The reason behind if there is a same IP ranges coming up from the on-prem or your offices with a cloud, then there would be the overlapping when you plan to do a site-to-site VPN or you can have connectivity. So IP ranges decision is very important to get this 10 dot series ranges or 172 dot say series ranges if that is not being used anywhere in your on-prem or offices or anywhere. So yeah, based on that, decide that which try to deploy the VPCs, VPC using infra as a code, Terraform or CloudFormation. Um, so that will make sure that you have a private, public, and database subnet, right? So VPC creation is very simple. Just even in the console, we can go ahead and just give the IP ranges, and it will deploy your 3 layer of subnet. We generally want to adopt at least 3 AZ of these when we create the subnet. The reason behind, what happened is that suppose now I have created the subnet AZ1 and AZ2, right? And AZ3. So my one of my servers is running in AZ1 and one of my servers is running in AZ2, which means the data of our application which we are hosting currently running in two separate data centers, right? So even if your one AZ data center get crashed or anything happen with your one data center, still your application will be up and running from and getting served from the data center too. So that's kind of a failover can happen if you have multi-AZ setup and multi-AZ subnet created. So having a multi-AZ subnet created in your VPC structure, that would be good enough. So yeah, so when we create the subnetters, just try to make sure that you have a multiple subnet ranges that is being uh, deployed. So yes, I have just calculated like the three simple one, like when I am going to use the private, public, and then there's also a database subnet, right? So three subnet, three AZ, which means that total number of subnet I'll be having a 9 subnet. Okay, 3 plus 3 6 and 3 plus 9 in each AC. So I definitely have a VPC. Maybe I have the VPC subnet Terraform code. I'll share across that Terraform code how to deploy the VPCs. Maybe I can share across in my repo as well. Yeah, once you deploy the VPC, right? So how to connect and get this centralized outbound traffic monitoring. So there's 2 layer of monitoring happening, or when we decide the networking, we have to make sure that think of that your network team or anyone who's sitting who wants to monitor your all your networking egress traffic, right? Suppose anything you have spinned up one machine here, right, or your database machine here, and some malicious thing is happening from here and it's trying to connect to malicious URL, right, through the outbound internet. How would your network team connected? They know that this is coming up from the malicious request. So something you should be think of, like now you're going to eventually you can grow your number of account, right? Currently I will take an example of 3 account, but in future you can grow till 10 5 20 accounts based on your application requirement. So the network component will be getting more complex. So we need certain approach where we can centrally monitor your egress traffic and outbound internet traffic. So in AWS, we have a service called Transit Gateway. Transit Gateway or VPC peering is kind of concept where it can connect your multiple VPCs and route your traffic through central approach. So in my this architecture, what I'm mentioning here is I'll be also hosting one more account called I'll be also hosting one more account calling network account, and this network account is definitely going to be managed by a network team, right? So whole and soul this account access only be granted to your network admin, and they'll be taking care of deploying a firewall, they're deploying a VPN, everything will be getting done here, right? So they don't want to bother about connecting to your production staging environment and making changes at the network level. No. So the moment you create the VPCs, you have to create your transit gateway attachments. So this example I have already shown in one of my videos, like how to create a transit gateway attachment and associate to your hub and spoke model. So yeah, this is nothing but it's a hub and spoke model, right? So we have our network hub, right? And these are all spoke models. So these are all spoke VPCs where you are going to host that. So any traffic from this application will be terminating on transit gateway attachment, which connect to your transit gateway hub, right? This is my transit gateway hub. So what happened is that in this architecture, what benefit we are getting is your egress traffic are getting filtered out. So suppose we have one machine running here, and it want to connect to internet to download some packages, right? So it will come on the transit gateway here, and from here it will come here to the transit gateway hub, and then from here it will go to your firewall, right? So AZ1 or AZ2 or AZ3. So here we have, either we can bring up the network firewall in this layer where we have the filtration of IPs. Suppose we have a malicious rule saying that anything comes from this, anything which is trying to connect to this malicious IP should get blocked, right? So that layer of restriction get happen and filter out here. So it's very important. Also, like I also managed to take care of the DNS firewall. So DNS firewall is AWS DNS firewall, which I kept in the network account because we can easily manage all your DNS rule from central account. But the DNS firewalls are associated to your VPCs, right? So I have given this icon saying that associate the DNS firewall with your VPCs, which means DNS firewall has a two layer. One is the AWS managed rule layer, and one is the AWS customer custom managed rule, right? So what is the difference between those? AWS managed rule is like a set of rule which gives you which is listed down all the malicious domain URL. We don't have to manage any kind of a URL which is being currently there in the market, like in the internet, right? So AWS by itself take care of all the malicious domain name URL up to date. And that's a free of cost. I have also done some videos on DNS firewall, so that just refer that if you need more information on that. So yes, so we have the DNS firewall where all your traffic, if you're trying to connect to your facebook.com, or if you want to make sure that Instagram or WhatsApp, we don't want any of your machine to connect to this URL. Definitely, it can. You just have to define that rule into your DNS firewall and get associated. So any traffic trying to connect to your facebook.com from this machine, it will get blocked by a DNS firewall, right? So that's the importance of having DNS firewall. I hope this is clear. So yeah, we have covered the transit gateway hub. We have covered that network layer, like how the egress traffic coming, and we covered the DNS firewall, right? Now the fourth point is regarding the centralized VPC endpoint, right? So I think I have also prepared one video on the centralized and decentralized VPC endpoint. What is the benefit and of having and not having, right? So centralized VPC endpoint is nothing but it's an interface service which AWS has created under VPC section. So you'll find a VPC endpoint service are there. What it does is generally, suppose there are thousands of services in AWS. Taking example of S3, DynamoDB, and different services are there. So if you want to connect, if any of your services which is running here in the private subnet, suppose I have one machine running here, that it want to connect to one of the S3 bucket, right? Maybe S3 bucket is also running in this account only. But if you want to connect to S3 bucket, it will definitely go through the internet. Like it will go to the internet here, transit gateway, NAT, and then from NAT it will try to connect to this S3 bucket via internet way, right? So what AWS say that don't use the internet NAT approach to connect the S3 bucket, since the S3 bucket is fed into your account, and it's a AWS managed service. Why not you can use a private link to connect your instance with the S3 bucket, which means we just have to use the backbone network to connect the services. So what benefit we are getting is like all your source and destination is happening within the network, within the data center. We don't have to cross that the internet and go from the internet. Using And the other benefit is that anything from the internet, right? Suppose it goes to the from here to internet, definitely data transfer is happening. So data transfer cost is also getting impacted. So the recommendation is avoid having anything if it's available. The VPC endpoint gives you security at the layer, and also it try to save your cost on egress traffic, outbound data transfer. So data transfer cost will be getting limited. So yeah, that's the benefit of having the centralized VPC endpoint. So we managed to cover that as well here. Um, yeah, the private hosted zone. This I have covered. This what I have. Why I am putting here as a practice, because we can, if the organization want to use the private domain name for connecting the services one by one, right, within the network, they can try using the private hosted domain name, and that private domain name can resolve within your this network, every network. Take an example. I have the domain called example.com, right? This is a private domain name. I am hosting in my network account. We're using this one. So this can be resolved by all your VPCs, right? Since it's connecting in a transit gateway, we just have to do a association of that. So I'll be creating one video on this as well. So how to create the private hosted zone and associate and disassociate the VPCs on that. So that's an important concept. Yeah, I think we have covered this. This also is covered. Um, so what is the benefit of having the multiple NAT, the each layer? So suppose now if you see, like, I'm having three AZ, right, in my network account, AZ1, AZ2, AZ3, right? Uh, uh, Anything like, suppose your data center one is getting down, right? Which means any request coming from the AZ1, suppose you only have the NAT one, right, for all your outbound internet. If your data center get down, which means outbound internet won't be there, and your application might get impacted. They won't get the services up. So it's good practice to have a failover. So for your all your egress traffic, so NAT gateway having an each AZ is recommended. I have kept very simple and without much investment, so how we can manage these network component. So the reason behind I haven't involved the AWS firewall here. The AWS network firewall is good service, but it is expensive. It is like it has certain cost. Uh, um, should be definitely getting implemented in enterprise. But if customer or anyone doesn't have a budget, right, we can plan to use a NACL. NACL also gives you a IP based restriction. Definitely it has some limitation, like we can only maintain 100 IPs blocking, but it allows you to do the IP based blocking. So if you have heard about IDS and IPS, right, that's an audit term where how you can do the detection and prevention kind of thing. So for the prevention method, we can use IP-based blocking and DNS firewall, right? So these two services are very negligible. It's a free of cost service, right? So using this method, we are able to cover and make our network posture proper, and this is useful. Okay, so now this is covered. Now I'll be taking example of, like, so we managed to show you, like, multiple account VPCs, how the traffic is going from here to center places. Yeah. So we covered maximum point on the how the centralized network model should be. I have also kept a Cloudflare VPN hosting, how you can connect your private servers through your VPN, right? So in this network, I'm taking example of Cloudflare VPN, but it can be anything, any VPN, like if you're going for the open VPN or any component. So generally, in order to connect your any private resources or private URL, we need to have some VPN, right? So having one tenant in a VPN on that too hosting in the network count will help us to yeah, to manage a VPN component. So yeah, and after that we also have, like, if suppose if you want to bring and connect your external partner, right? External partners who is currently a bank or anyone, right? How would you connect to because mainly what happen is that either you connect via site-to-site VPN privately, or either we have to do some restriction, like we have to share our outbound gateway IP, so that banks or external partner can, or at least into their applications, and we can get that. So many times they will come up asking about send me your gateway IP, right? So we have to send a NAT, these three NAT gateway IP, so that to the external partner, so that they can connect, our application can connect to the external partner, right? The other way is like we can use a site-to-site tunnel, so we don't have to do anything with your other workload account. So site-to-site tunnel can be built here into network account, and using transit gateway route, we can just transfer the traffic to the individual VPCs wherever you want. So these are the two approach where and having this network account, central network account, is benefit that you can manage all your network component in the one specific account itself. Uh, yeah, connecting the Cloudflare example, right? I've kept. Now I'll talk about the other region, which suppose you are also going to manage some different region like Mumbai, Singapore, or Hong Kong or Jakarta, right? So we can we can host, like suppose I am having a different account, different application requirement which need to be hosted in Hong Kong, right? I will just spin up the account and get the VPC set done in that account, and make sure that my DNS firewall is attached to the VPC, and we have outbound internet is getting traffic is getting associated to your transit gateway attachments, and from there it will get terminated to your transit gateway hub, right? Same thing, we can connect here, and the traffic from here, traffic from this Eastern machine, it will go from here through your transit gateway hub, and from there it will go to the internet, right? So outside, that should be the same approach we can do here. If you want your private this machine to connect to one of your application which is running here, right? Maybe this machine, right? How you can do it privately, right? So basically it can be achieved. We simply have to build a uh, TGW peering, right? So between this, so my HK and network, so it's a cross region peering is possible now. So and it's a once that transit gateway peering for cross region is completed, anything come from here, it will go to your transit gateway hub, and from there it will travel to your transit gateway hub, and from there it will travel to your bridge of transit gateway peering, and comes to here, and then it will again go back to your private network, right? So it's all about a networking routing tables that we have to manage. I'll definitely cover one videos on how to connect cross region transit gateway peering. So uh, and that will be useful for you to connect a multi-region. So yes, the hub and spoke model allows you to maintain your network posture centrally, and it allows you to control your all your egress traffic, right? So that is there. For the ingress traffic, I think ingress traffic is something nothing but the HTTP traffic, right? So suppose have your application hosted over here, and you have a load balancer running on the public subnet, right? So yeah, the traffic, then this public subnet has a internet gateway route. If you see that I have mentioned the internet gateway route, so which means that any user wants to connect to XYZ, example.com, right? So it will just directly come to the load balancer, and from load balancer it will stop here, right? So that's the ingress traffic. So here, what will come as a security? We have to build a WAF, right? So WAF has to be there, which will be controlling our all ingress traffic. For the egress traffic, like outbound traffic, as I said, like we need to have a DNS firewall, we need to have a network firewall, right? But for the egress traffic, we need to have the WAF that will control all your HTTP traffic from the outside. So yeah, I think that's what I wanted to cover. I hope this information was clear in terms of networking, how the posture should look. But yeah, please let me know if anything else need to be covered in the comment. Thanks for watching. Thank you.